Incredible, right, guys? What do you think? All right, I'll hang on tight. Just hang on tight. And so this is, if you look at the world's models, there's no question OpenAI is the leading token generator today. More OpenAI tokens are generated than just about anything else. The second largest is probably open models. And my guess is that over time, because there are so many companies, so many researchers, so many different types of domains and modalities, that open source models will be by far the largest. Let's talk about somebody really special. You guys want to do that? Let's talk about Vera Rubin. Vera Rubin, yeah, go ahead. She's an American astronomer. She was the first to observe. She noticed that the tails of the galaxies were moving about as fast as the center of the galaxies. Well, I know, it makes no sense. It makes no sense. Newtonian physics would say, just like the solar system, the planets further away from the sun is circling the sun slower than the planets closer to the sun. And therefore, it makes no sense that this happens unless there's invisible bodies, we call them, she discovered dark matter, that occupy space even though we don't see it. And so Vera Rubin is the person that we named our next computer after. Isn't that a good idea? I know. Okay, Vera Rubin is designed to address this fundamental challenge that we have. The amount of computation necessary for AI is skyrocketing. The demand for NVIDIA GPUs is skyrocketing. It's skyrocketing because models are increasing by a factor of 10, an order of a magnitude every single year. And not to mention, as I mentioned, O1's introduction was an inflection point for AI. Instead of a one-shot answer, inference is now a thinking process. And in order to teach the AI how to think, reinforcement learning and very significant computation was introduced into post-training. It's no longer supervised fine-tuning, or otherwise known as imitation learning or supervision training. You now have reinforcement learning, essentially the computer trying different iterations itself, learning how to perform a task. The amount of computation for pre-training, for post-training, for test time scaling has exploded as a result of that. And now, every single inference that we do, instead of just one shot, the number of tokens, you could just see the AIs think, which we appreciate. The longer it thinks, oftentimes it produces a better answer. And so test time scaling causes the number of tokens to be generated increase by 5x every single year. Not to mention, meanwhile, the race is on for AI. Everybody's trying to get to the next level. Everybody's trying to get to the next frontier. And every time they get to the next frontier, the last generation AI tokens, the cost starts to decline, about a factor of 10x every year. The 10x decline every year is actually telling you something different. It's saying that the race is so intense. Everybody's trying to get to the next level, and somebody is getting to the next level. And so therefore, all of it is a computing problem. The faster you compute, the sooner you can get to the next level of the next frontier. All of these things are simultaneously happening at the same time. And so we decided that we have to advance the state-of-the-art of computation every single year, not 1 year left behind. And now we've been shipping GB200s a year and a half ago. Right now we're in full-scale manufacturing of GB300. And if Vera Rubin is going to be in time for this year, it must be in production by now. And so today I can tell you that Vera Rubin is in full production. You guys want to take a look at Vera Rubin? All right, come on. Play it, please.